Hello everyone, thank you for coming here still at the end of this day. Not everyone left yet or is still flattened out from the party yesterday. Good to see you all. We're going to give a talk about a mirror on the wall and how we use blue team techniques in our red team operations. It's Mark and Mark, as you already heard. I'm Mark Bergman. I started before 2000 with a bank programming COBOL. I'm not yet the average developer though. I was reasonable in writing code that works. I was not that good in writing code that's actually finished and has all the ifs and elses. But it got me going and it was good enough for me to dive into C and a lot of other languages and finally moved to offensive security around 2004. Worked for a big firm for 4 years and went self-employed after that. And by now I'm full-time doing red teaming. And I'm usually the guy that gets asked, can we have 25 new redirectors and 4 backend servers for a new big op? And that's what I built. I tend to be quite lazy, so if I type a command 3 times, I think that's more or less the limit, and it's time to script it.
Okay, thank you. Thank you all for being here. My name is Marc Smeets. Somewhat similar background like the other Mark. We used to work at the same company. Now we started a new company solely focused on red teaming. My own background is more on system and network engineering. I used to do that before going into offense around 2006. If you're on Twitter, you might follow me for some ramblings about infosec, sports cars, champagne, all kinds of stuff. If you only want to follow stuff about our company, what we're tweeting about the red teaming stuff, then you can follow our Twitter account of the company itself. Our company, Outflank, it's a Dutch niche company solely focused on red teaming. We've been existing now for 2.5 years and we're solely focused on red teaming, which is also the topic of today. Sadly, this is still a visual of how most people, both providers as well as customers, tend to see red teaming. Full, no limits, wrecking ball type of engagement. Everything is allowed, all for the same goal, to get to the crown jewels, whatever means are necessary. So every means necessary is put into the engagements. That can be from regular phishing to physical access to very fancy exploiting to all kinds of different techniques, just solely for the end goal. The end result most of the time is just full knockout for the blue team, which can help for making an impact, but is not always per se really helpful for the blue team itself because, well, they got knocked down and now they're having trouble getting up. The learning effect of such a type of engagement is really not that big. So that's a really big downside, and that's not the way how we see red teaming. We like to see red teaming more as this, as boxing, as sparring, trying to help the blue team to improve. It's still real punches, real movements, real combos. The punches still hurt, but more an exercise environment where we tune our level to the level of the blue team in a way that they are excelled in their own expertise. We try to bring them up a level. So it's fundamentally different. To put this into perspective, how we see the red teaming that we do compared to other types of security services, this is our view. It's not per se that we're saying this is the truth, but just to give you an understanding of how we see things. If you would compare red teaming to pen testing would be way more efficient. It would be less realistic. So you can divide within a few axes, realistic versus efficient, and assessment versus exercise. Purple teaming, for example, would be way more of a true exercise and more efficient, where red teaming would be way more realistic. The same goes for hacking to hit caught, and the same goes for CBEST. CBEST is the red teaming framework from the Bank of England. We tend to do many red team engagements via the Tiber framework. So where we put red teaming, the same goes for Tiber. It's more realistic compared, as the way we see it, compared to the other frameworks. You see also that it kind of fades up. That gives us the opportunity during an engagement, during a red teaming, to either make a second scenario or a third scenario where we are leveling down, so we are easier caught. it also allows us during the engagement to get caught. We might fly in under the radar, try to get our nice channels up and running, try to go for the gold. In the end, if we're not caught, just scale up our visibility. Drop mimikatz.exe on a domain controller, let's see what happens, that kind of thing.
We really think this is a must-have for red teaming. If you guys, I'm not sure how many red teamers are there in the room. A handful, blue teamers? Yeah, I would say keep challenging the parties that bring red teaming to you as well. I think if during a red team there's no detection, then the red team failed.
Yep.
Most people tend to see it the other way around. The red team makes a dance if they can get to the crown jewels without being caught. But where's the lesson in that? So a red team with no detection is a fail for the red team as well.
So, balance. I tried searching for a balancey thing with red and blue, so I found this. The reason why this is in here is that in every engagement we balance our level to the blue team. And during time we see blue teams becoming more mature, and they're trying, thankfully, adapting new adagios, new theories like assume compromise. So the blue teams they know that they don't need to solely focus on the external perimeter, but also focus on the inside of the internal network, assume compromise. So the same goes for the attacker's playground, where they use the internal network to set up traps where the attacker can be caught. It slows us down, which are good things. So the blue teams are getting more mature. And at the same time, the red teamers are having a more difficult time because there are more demands to the red teaming being performed. Multiple scenarios, bigger engagements, multi-team member, bigger infrastructures. The red teamer's job is becoming harder, which is a good thing, by the way. The last thing that we want to do during a red teaming engagement is that we are being caught, and immediately the blue team thinks, well, this is not a true attack, this is a red teaming, so we should not be going into the stress mode because it's just a red teaming and it's just an engagement. We don't want to pull all-nighters to do the proper investigation. So when we are being caught, we need to think about the way that we're being caught in order to still to get to that stress level at the blue team side.
We're sort of planning on being caught, and also planning on how to move forward from there. Because in our opinion, when we get caught or when we get seen, part of the operation gets seen, that's where the game starts.
Yeah. So we need to level up. We need to become more mature. We need to be more in control. So that led to a few questions that we asked ourselves. How can we become more in control of our ever-expanding bigger infrastructures? And if we're more in control, are there possibilities that we can detect that the blue team is detecting us? Can we see that in advance? And can we use that knowledge to maybe extend the whole operation and make a better operation? That got us thinking. And to cover that all, we're going to answer this question, we're going to cover three topics: the advanced infrastructures that we are using with the red teaming, how to monitor all the relevant events, and how to do the analysis detection. Yeah.
Yes, before we dive into this detection and how that works, I think we first have to cover some basics on what does red team infrastructure actually look like. As most people pen testing, they have their laptop, likely with a Kali installation. That can be more or less the basis where you start doing pen tests. But as we really see that red teaming is a totally different kind of game, you will also see that there's more components involved. I think the typical components every red team should use, or will use, is a backend server, the C2, the team server, or the command and control server, where the main operation takes place. We tend to use a lot of Cobalt Strike, so in the rest of this presentation you'll see that once we're talking about C2 traffic or C2 servers, it's often aimed for Cobalt Strike, but the same would go for PowerShell Empire, Puppy, and all the other parties and all the other products.
Any Cobalt Strike users here? Okay.
A handful other tools often used, PowerShell Empire, Puppy.
All of the above.
Yeah, all of the above, yeah. Well, I think everyone has to you need to have your servers to have your incoming connections, and also I think it's quite common, at least I hope it's quite common by now, that everyone uses redirectors in their infrastructure. Domain front ring is a technique often used, was possible through Google, they changed some things there, in Amazon it's still possible, and it's a bit shifting technique.
It might be still possible in some certain cases, maybe hint, hint, hint. Yeah.
To go with Google, yeah. Throwaway identities, I think everyone deploying Red Team first needs to engage their victim, and you start on the most social level. We tend to do a lot of LinkedIn identities or email accounts that we can use to initiate contact without giving away who we are, of course. And then the one that might sound real normal, we use a VPN to browse. Doesn't everyone do that? No. Now and then we hear of situations where the Red Team maybe just visits the website of their future customer and does that through a VPN. Well, if there's just a slight hint during the operation that might be a Red Teaming going on, you would be surprised how quick sysadmins go searching through logs whom has visited their infrastructure. So yeah, do that through a VPN. And I think the component that might not be that commonly used, but we tend to use them, multifunctional redirectors. So we don't use a redirector just to forward traffic. It does a lot more in our infrastructure. Web-based file servers for serving files. We tend to use HTML smuggling a lot. HTML smuggling is a technique whereby we don't offer a file to download, but basically we offer a HTML site with JavaScript in it, and on the browser of the victim, the JavaScript will assemble the document and deliver it for a local download. That means that we're already past the proxies and all the scanners. We're already on the endpoint, so endpoint security might still be in our way, but we're already on the endpoint when the Word document with macros gets assembled. And then we use tracking pixels, like you would see in marketing emails, and we use a lot of them. If we send out an email, we want to know if the email is read. And if the email is read, we want to know if it's the email client that's reading the email, or if there's a proxy in between that's pre-scanning every address. And then once we know the email is read, we want to know if the document is opened. So if just the Word document is opened by the victim. And if it is, we want to know, even though whether or not the macro ran, we want to know if he started the macro. It might crash during its process or something might go wrong, but we want to know, did the macro, was it triggered? And then we expect to run some payload. And we also want to know when the macro should be finished. Just in case something goes wrong, we want to know exactly where to start debugging. It's sort of a remote debugger by placing pixels everywhere that get requested from our infrastructure, so we see when they get requested. That's a more graphical picture for the same items. We've got in the red we've got the backend servers, and we never ever talk to these machines directly. Quite often, if we use graphical interfaces on our own systems, even then we work through redirectors. You can never ever make the mistake, this red area, so our own backend, you burn that quite fast, and it's quite hard to maintain and hard to build up. We do build it up per client, new systems per client, but you don't want to be cycling through those. For a few reasons. First of all, and I think that's the most important, and we're most certainly not too lazy to build a lot of these things, but they're on our own hardware. Sensitive data of customers might be on these machines, so we're not going to do that at some virtual machine. It's going to be our own bare metal where we build up this infrastructure. So that for one is a reason that they're not easily replaced. I've got only so many IP addresses and IP space to give away there. And then the layer in between, the redirectors, we tend to spin up VPSs at DigitalOcean, Amazon, and well, we can dispose them quite easily. That's, I once had to make quite a race for it to see how many I could start, and I could get it up to like 40 a minute for the more dumb redirectors. So if we have a client who thinks he can kick us out by just blocking IP addresses, that's a race we usually win. The more complex redirectors do also SSL certification. They know that traffic not for the backend to send somewhere else. You can see it in the bottom. There's an application server that might get some of the traffic directed towards them. That means we can also measure what goes into our Cobalt Strike backend and what's other noise. And this other noise, that's where it gets more interesting later on in the presentation. To flatten out this picture, this is basically what we have. We've got the target network, we've got redirectors, a layer of disposable machines, and we've got the back end that we are more keen on keeping secret. But basically, there's a lot of systems. For one operation, for one client, if we have one big red team, we quite often run 2 or 3 scenarios. That means that for a certain scenario, we decide how advanced do we want to be. As we told in the beginning, we're not always going in as advanced as we can. Sometimes we choose one scenario to be pretty advanced, and one scenario we use bot files, link files, everything that's script kiddie style. But it can be really useful to tune yourself down to try that. But it already means we have at least 2 backends, 2 team servers, likely even 3, and we'll have a few handful of these redirectors, just for one client, one operation. So as you see, it's quite fast, getting more complex. And then we want to know, yesterday, where you ran this command on the one machine, what's the outcome? And we have to start grabbing through logs. We have to SSH into one of these machines, use grep to find the commands in the log files. It's a lot of work. And also, if something happens on one backend and thereafter on the other, we cannot correlate this information. It's not linked together. So there's no easy way to access all the data that's scattered over this infrastructure. And that's something we really need to fix.
This is me? Yeah. So we want to centralize all those logs, and we want to centralize all the important traffic logs and all the important operational logs from the stuff that we typed into our team service, Strike. And in all those logs, there are actually really relevant information, so we need to get that all. We want that because we want better situational awareness. We want to know what is going on. We want to also get historical searching through the operation, just like Mark said. Enrichment. Any type of information element within the log, we might be able to enrich, and rich is better, so more information is better. And maybe build some real-time dashboards. People tend to like dashboards, and they can give you some nice overviews for us, but maybe also for the white team. So maybe the white team, instead of querying us for specific information, they could have a dashboard with specific IOC measures or specific desktops that might have been compromised, stuff like that.
Is everyone familiar with the term white team? If you do a red team operation, you've got the group of attackers, us or at least some aggressive team attacking the customer. You've got the blue team, of course, which is the SOC, security operators trying to keep everything safe. They tend not to know that there's a test going on. They just feel it as a real incident. And then we've got the white team, where it's the red team, including a few guys at the customer. And they are in place to make sure that things don't escalate and things don't go really bad. People don't get fired if their name hit up in a log, or that the police isn't called or is called, whatever the terms on the agreement are, but at least you need to monitor that. That's what the white team is.
So we want to give them information, we want to give them some auditability, if you like. And also, again, we want to centralize the logs, because if you ever used Strike, and for the few users here, they will, you know what kind of a bitch it is to search through all the tens and hundreds of old beacon logs and trying to find that specific piece of information. It's a great tool, but it's meant for live hacking, not for historical searching. So we've got some challenges there. One more thing to note. We're talking about traffic and operational logs, so we're not interested in like the base operating system, SSH stuff, and failed authentication. That's like a different category. But centralizing logs and gathering it together kind of sounds like a problem that the blue teams have already solved a few years ago. So that way you can either go with Splunk, or you could go with Elk. Splunk is commercial, fancy stuff, but also has some drawbacks. And we wanted to go open source, so we went with Elk. But because we are a red team, and in advance I apologize for the bad graphics, but we needed to have an Elk for the red team. So we are creating a red Elk. And we will be releasing this tool right after. So red Elk, in a nutshell, it's a SIEM for the red team. We're using Elk. So it's entirely based on the Elk stack. We're gathering operational data from Strike, and that's what we're supporting right now. So it's giving you a view of all the operational data, as well as all the data that might be some way indicated. Could be an IOC. So we're talking about traffic logs, but also the IOCs that are coming from Strike itself. We want all that information together, one central location, better situational awareness, and like Mark said, we have infrastructures that are quickly expanding, so we need to have the installation automated, easy, that's what we're doing. So the current status of Red Elk, as we will be releasing right now, is it does all the log aggregation for Cobalt Strike and for HA proxy. That's the tooling that we're using. Another option would be to use Apache. Many people use Apache, and for the ones that of you that are looking online for some information about the red teaming infrastructures, a lot of other teams are actually using Apache. We made a decision some time ago to use HA proxy. We like it better, but Apache should not be that easy to implement.
There is quite a few open source stuff at the moment on using Apache.
Especially the blue screen of Jeff wiki has some good information, but yeah.
Yeah, but by that time we were already halfway with our hproxy config, so that it was.
Yeah, also, and the logging, which is detailed there, does not go into the detail that we're doing, because we are doing very, very fine-grained filtering and logging. So if you compare this to Cobalt Splunk by Vincent, I forgot his last name, that's cool, but it's like a generic overview, quick and generic. This, what we're building, is way more advanced, way more better filtering. We're chopping up all the fields, so you can do detailed querying. Also, log enrichment. We want to filter out all the test beacons of our own testing systems. We don't want to know about that. It's in the stack, it's in the Elk stack, but we can just simply filter all the data out. So it will not appear on dashboards, it will not appear in historic searches, stuff like that. We want to tag known good and bad traffic, GYP lookups, all, and etc. I want an easy querying of screenshots, keystrokes, IOCs, operators logs. We just want to have a better interface than the default Cobalt Strike interface.
Yeah, there were only, I believe, a few Cobalt Strike users in the room here, but I'm not sure if any of them wants to comment. Have you ever tried searching back in the screen output of Cobalt Strike and copy pasting stuff? And did that work? It usually breaks quite hard. It's a Java-based screen, and it's functional for using it live. It's not functional for going back in history.
Yeah, exactly. And then again, when we have the data, we can do some smart dashboards and queries, aggregations and stuff like that, because it's in the Elastic stack. And then if we have the data, maybe do some smart querying to see what the blue team is up. So to go back to the overview that we just gave, we're using the data feeds, simply just file beat, which is installed on the redirectors and on the team servers. It pulls all the data to a Logstash, which does the heavy filtering, which puts it into Elasticsearch. On top there's a Kibana interface. But you see on the right there's a second data copy stream, because we also want to basically just rsync all the data back to our own system. We want that because in the interface, we just want to click on a simple link to get all the screenshots of all the different team servers. If we have 10 team servers, we don't want to be logging into each team server to, again, scroll through the screenshots. No, we just want to centralize everything, easy clicks, easy queries, easy overview. And in a nutshell, we do indexing, enriching, searching, dashboards, SIEM, etc., etc. I want to quickly go through how Cobalt Strike actually has its log setup. The reason is that Cobalt Strike has very detailed log, but it's not in the default way that syslog actually works, and every specific log that Cobalt Strike uses has a different setup. So the type of data is in a beacon transcript. That's just the output of a specific session that we have. That's a full transcript of every input, every output, all the commands, all the outputs are in there. It's in the specific date folder, based on the IP address, based on a beacon _ beacon ID. And the beacon ID is like a unique identifier ranging from 1 to 100,000, which is an identifier for this specific beacon session. So there's a very, very, very small chance that there's an overlap in beacon IDs. We never experienced it, and well, even if there's a duplicate, we don't care. We can still work around that. We want to have that beacon transcript in it. We also want to have the screenshots that are created on the targets. And those are in a different directory. We need to scrape them. We also want to have the keylogger output. And there's like this generic central event log where you can chat with all the other red teaming operators and you could put in generic information. Is it relevant? Somewhat. It is being indexed. No heavy filtering on that because we don't see any use for it yet. Then there's screenshots, not of the target, but of the Cobalt Strike interface itself. Can be useful if you want to show the very big diagrams of, hey man, we had 100 beacons, which in theory sounds nice, but in the latest release of Cobalt Strike, it actually crashes above a few amount of beacons. So, but yeah, at the moment we don't sync those yet, but we will be implementing that later on. Every once in a while there's a failed beacon. We don't know why. It could be somewhere in the process it just fails. It has no beacon ID yet, so that comes into an unknown directory. Most of the time it has no relevant information whatsoever. It is being synced, not being indexed. Then there's a web server log and a downloads log, which are not really useful to us because the web server log, we already have all the web traffic from the proxies, which we'll go through later on, and we do not tend to use the whole website functionality that Cobalt Strike itself has.
We tend to use Cobalt Strike for what it's good at, doing the beaconing and serving payloads. Cobalt Strike can do that, but we tend to solve that on our own, and we'll get into that later. So there's a reason that we don't need the server logs. We don't use the functionality at all. No URL will ever point to that part of Cobalt Strike.
Exactly. And then there's the downloads log, which is fun, but nothing really fancy because we already have all the downloads within the beacon transcript, so we already have it. Big important thing, you could use aggressor script, which is the scripting language on top of Cobalt Strike to do all fancy stuff. We tend to use just the basics, no extra scripts because, well, we already get all the important stuff.
We don't use the script to generate logs because we do use. We've got our own virtual assistants that does a lot, which is a big CNA script. But well, for logging, we don't use it at all.
Yeah, exactly. Just to go quick through, this is one of the beacon transcripts, and one of the important things to mention here is that it's multi-line, and every rule line can be different. So it starts with, on the left, like a timestamp, and then the first line of every beacon transcript is really important because it has all relevant metadata. Internal IP address, external IP address, the target's host name, the target username, the architecture, stuff like that, all the relevant information. All the other lines do not have that information anymore. So if you would just process this as it would go through, you would lose all the relevant information. So that's why we need to get that information, extract it, store it somewhere else, and then inject it again with all the different lines. I will show you later on. There are inputs, tasks. In this case, Mark entered the get system, which starts a service. That results into an IOC, which is being printed over there, that got indexed. And then we ran a screenshot and we did some logon passwords to get Mimikatz output, which is multi-line.
You can see here that it's totally different from how you would find log lines in syslog, where all the information is always on the same line. Yeah. That's not the case in Cobalt Strike. So, looking at the HA proxy logs, that's more like syslog type. The important things here are that there's like the basic syslog identifier, and then we have a front end and a back end. And the front end is like the interface where the proxy got the incoming traffic from, and the back end is how it's, after all the filtering rules, decided to go for the specific backend. So in this case, traffic came in via the interface that we defined, that we named www.https antivirus on that specific IP address, and we redirected to the backend www.decoy. You will see that the IP addresses mentioned also include the FFFF, which is nowadays Linux mentions IPv4 addresses when you have IPv6 enabled in this way, and we filter out those FFFs already in Logstash, so no worry there. Maybe it's good to add something on why we split on our redirectors. We split the traffic so much. We have our C2. So our command and control data that goes to Cobalt Strike, so we can actually steer the beacons that are out there in the field on the laptops. But if we have an investigator, a technical investigator searching for one of the URLs we use, we like to catch that URL. If it's just a get from / or index.php or whatever, we like to catch that and send that to a decoy site. In our case, it's quite often a locally hosted Apache on another port, and it might show some complex JSON, which looks like financial information. So even if the investigator thinks it might be somewhat evil, in a financial institute, you've got quite some guts if you bring down an interface that might be a valid API. So it's also already a reason to trigger the blue team in thinking ahead and thinking further. So the decoy side in our case is often not an empty side. It actually mimics something that looks important.
Okay, and then if you want to have the full user agent and the full body, you need to use those custom login format that we have within HA proxy. If you don't use that, you will not get the information, and Red Elk requires this, so yeah. So we got all those logs, but they're just logs. We want to enrich them. We want to be like the cool granny. We want to be super cool, enriched with all the bling bling. So how do we get more bling bling? Within Cobalt Strike, we remember the first line with the metadata info. We inject it every time again for every specific rule. So every line that is being logged has that specific information. Makes it easy to query for specific host names, usernames, etc. And for the redirector, for the traffic data, we do all the GUIP, reverse DNS, see who the IP block owner is. That will easily let you identify if you're being queried by, for example, say Symantec, which does all the scanning from their own IP block, which is marked as being from Symantec, so you will easily identify that.
This is a call to Symantec as well. Guys, if you start scanning stuff on the internet, don't do it from your own IP block.
Okay. We do some background processes that do system classification. We set tags for known test systems and known sandboxes, and the same goes for on the traffic data. If it's a Tor node, we tag that. If it's within the IP list of the customer that you're attacking, or if it's your own red team that's being connecting, we set a tag. There's also a list, IP list unknown, for which you do not know what it is just yet, but you want to suppress the alarm. You see the IP address coming in every time, but you want to suppress the alarm. You put it in there. And then there's gray noise. Hands for people that know gray noise. There's a few, okay. So for the rest, gray noise is a scanner for internet scanners. And it indexes all the different scanners that are out there. So that one of the scanners could be Shodan, or it could be Google, or it could be one of the universities doing international internet-wide scanning. Gray noise indexes those, gives them a classification. It also includes all kinds of vulnerability scanners that are just scanning for a specific Apache query vulnerability or specific telnet vulnerability, stuff like that. For us, it's really important because if gray noise has knowledge of the IP address that's connecting to us, it's like a normal generic scanner. It's not going to be the blue team. So we include this data to have like a Boolean filter. Well, if gray noise knows it, not interesting for us.
And actually the other way around is even more interesting. If we get scanned by an IP address that gray noise doesn't know,
yep,
then it's someone who chose himself to specifically scan us.
Yeah.
That might be blue.
Okay, and then some usability improvements to get quick hyperlinks, which I think I can just show you. Let me see if I can get this somewhat readable. Welcome to Red Elk. You see the fancy logo? I apologize. He made me do it. So, welcome to just a normal Kibana interface. From here you can go to like the fancy dashboard that everybody likes. This is a dashboard showing the current or the historic beacons from the last 30 days. So on top right you select the time. Amount of beacons. We use this setup for just generating some documents and sending it to VirusTotal and some other public scanners, and we got beacons back. You can do selection from specific users and specific systems, stuff like that. And the top user in this case was that specific user. Different dashboards also for traffic. People like seeing the globe, so that's why we put it in there. And you make a difference between all the traffic, and maybe you want to specify between traffic being destined for Cobalt Strike and all the other decoy traffic. So easy overviews. This is just the basic. This is included into Red Elk. If you install it, you will get this, but you, of course, you can adjust all to your liking. So let's go searching. The most important thing is to click the open thing and you will get an overview of IOC's keystroke. This is just typical links for easy to see overviews.
It's queries we use on a daily basis. While we are in the operation, there's likely one tab open on our browser to be able to go through this.
Timestamp the specific attack scenario that you gave with this operation, and then there's the user, target internal IP address, the beacon ID, target host name, target OS, target Windows version, and it's not really big enough. Of course, it also includes the specific command that was being entered. This is just a simple overview. The full data is in every record, so it will give you all the different messages that you can query on. So let's say I want to see everything with this specific IP address, which is going to be from that specific redirector. So if you have multiple redirectors, you can select what just this query, the data you want to see from that redirector, and it will add there. This is just typical Kibana stuff.
It takes a while to get used to this, by the way. I've been cursing along for a few days, but once you get the hang, it's really quick to find stuff.
That was beacons. This is just traffic that you see from the redirectors. Again, you see the strings that we inserted into the HA proxy logs. It's right being directed here. You see the owner, the specific request that was being made, and stuff like that. So that's really helpful, and you can do the querying with this. But usability-wise, we want to see easy keystrokes, for example. Boom. And if that's not enough, then you can just simply click this link and get the full beacon, and there you have the data. That allows you for quicker searching, easier searching. How about seeing screenshots? If you're in a bigger operation and you have 100 different screenshots, then all you want to do is having a simple overview. You still remember that one single screenshot at the user's desktop where Outlook was open or that specific application was open, but you don't know on which team server it was anymore. Using this, you can click on the image, or you can just simply browse and have like quick thumbnails of it to have just that instant view. Click on it and you will get the full image. Anything else on here? You guys think this is useful? Fuck yeah. Thank you. A lot of work went into this, especially on the log stash filtering and the enrichment, and we're just giving this away because we think red teamers need to up their game. This needs to be available to everybody, so that's why we did the hard work. We do like you to actually help us improve this further, so do your thing.
Go and try it out. It's built to be disposable. That means installation is a breeze.
Yeah. So IOC's simple overview. It will print everything, the data that is within coupled strike, and of course this being Elasticsearch, you can simply just generate a CSV and we'll give you all the output, stuff like that. So I think
So instead of spending 3 days on making our final log when we write a report for the customer, you can just export a full timeline of what happened when, which commandos were entered and what the result was. Saves us a lot of time as well.
This thing I forgot, but if you're in the beacon overview, you can simply click on the link in every specific beacon rule to get the full transcript of the specific beacon, so you no longer need to search. Okay?
And then there is the silence lady. Now we can track whatever we are doing during our assignment, but that's not how we started this talk. And now we can see what we've been doing, see what the blue team did. But yeah, how do you see the blue team? They're back at the customer side, in some hidden room often, and you don't see them. But quite often, the blue team isn't as silent as they should be. Actually, not at all. And especially now, when we sit on this pile of gold, with enriched information, how can we filter this blue team out? The information we have is all the information about the C2 traffic we already have, and also all the information about any noise that might hit our systems. And somewhere in there might be blue. So there's another component added, and IOC sources. That's basically, it's a bunch of Python scripts that will query random, or not random, that will query a number of IOC sources and test hashes. We won't upload our own payloads, of course, but we can ask to a public a service provider, have you seen this hash before? And if we're lucky, we'll say, no, I've never seen that hash before. But quite often during the operation, we suddenly get a hit and it says, yes, I've seen a file with that hash being uploaded yesterday evening, and we know for sure something is wrong. At least we made a detection possible, and we need to up our game or shift around or start playing with that. We've just entered the next phase of a red team, basically. For now, we've made connectors to VirusTotal, which is rate limited, but with proper caching you can get around that, as we don't expect to query for new MD5s so much. We often have a few handful of files out there which we want to monitor. It won't be hundreds, it will be in the tenors, so that's okay within the normal rate limits of VirusTotal. Then we have IBM X-Force. It's rate limited as well. You can actually send an MD5 to IBM and it will give you the report for that MD5. And it's rate limited to 500 a day, I believe, so it sounds quite strict. But if they don't have the report for that MD5, you'll get a 404, and that's for free. So we can basically query the hell out of them, and only the hits will cost us.
Do not tell them. Do not tell them.
And then there's gray noise, already mentioned, which has quite a high rate limit, and we query them a lot as well. Basically, for every IP that we see in our external front end, we will query to gray noise. And that's how we can pretty much see what the blue team is doing. But yeah, then we know. What do we do when we see the blue team? First, we dig in. We make sure we've got a few extra exit points. We dig a few extra holes to get in and out of the systems.
I never saw, but it actually has blue eyes.
Yeah, it is the blue team. So basically we try to anchor ourselves a bit more, building our own backup lines. That's not necessarily a part of the training we're doing. And we tend not to start hiding the channel they found, because they found it and that's okay. That's something they can work with, so let them play around with that, and we'll monitor closely what they do, and we'll keep working over that line as well, because that's all part of the job, but also we'll make sure that we won't get kicked out permanently at least. So, mistakes that are often made by the blue team, I think I already gave one away: uploading samples to public services. It happens, it still happens now and then. Sometimes it's the blue team, as in the SOC or someone working in the SOC or a threat hunter, but also quite often it's just the victim. The victim got a Word document and it crashes or did something wrong, Word disappeared, for example, and we set the GUI to invisible, whoosh, Word is gone. Tries again, tries again, tries again. And after 5 times they think, oh, let's upload it to VirusTotal. If we see that hit quite fast, we know that it quite often it's the victim and not the blue team. If we get the similar behavior a few days later, then it's more likely to be a blue team uploading samples. But that's one mistake. For the blue guys in the room, do not do that. Recently we saw another one. We saw semantic scanners by themselves, and we don't think it was a mistake. We guess it wasn't a mistake of the blue team, but it was a mistake of Symantec somehow. Not sure how they upload their stuff or how they scan stuff, but they decided to trigger our URLs, and we're still investigating what exactly that was. And what also happens is that people start playing around with the payload. So now and then we have a beacon flying in just after 6. Well, that's usually some employee opening his laptop at home and doing some work there. But also now and then we see a beacon coming in over Tor. Well, that's not the average home user, so then we usually also have quite a strong indicator that something's going on. Manual visits. We often see once we're detected and they found the URL, our C2 URL, that they're going to visit with their Firefox browser, so there's a different user agent or the URL isn't complete or isn't fully there. That's also a clear giveaway to us that something is going on. We once had a profile that used favicon.eco, but that gets queried a lot by a lot of people. It was a bit harder to filter out. But yeah, once we know that blue is onto us, what do? Well, we throw them a bone. Let them play around a bit, let them chew on something, let them work. That's what they sign up for, right? Train themselves, and we help them do that in the best way possible to get better. By doing this over and over and over, they might get better and better and also more quiet. Now, how do we throw a bone to a blue team? For that we go to red file. It's a separate product which already was used by us for quite a while before Red Elk came along, but they combine really well. Because using Red Elk we can now see when the blue team did some detection and we can start acting on that. So that's what we did. What red file is, it's a small tool, a small Python module that you can run on a web server, and it will basically serve files. You don't need Python for that, you can just put a file on the web server, yeah, that's correct. But I want to be able to make this file behave the way I want it. And we'll get to that in a bit, but basically you can return any content with any content type based on parameters. For example, if the user agent is not what you expect, you serve something else. Or if a certain URL is queried for the 5th time, you serve something else. Or if a certain URL is queried without the office hours, you serve something else. Stuff isn't always what it seems. Ik heb hem even op.
Tadaa.
Ja. Let me see de tweede.
Denk ik.
Nee, this one. The last one. Oh, yeah. Well, this is one of our redirectors, flexo.strangle.net. If you're going to look for that in antivirus, you'll get a lot of it, because this is the one we've been trying catch me with a lot of antivirus parties by sending in malware to VirusTotal and wherever we could upload them. But here's a URL. URL is almost the same, but it has one unique key in it. If we look at that file, what we've seen at the customer, and we've seen it multiple times actually, that we send some malware out, and the first hit we get is some BruCON testing whether or not it's a reliable site. Yeah. So what we serve to the BruCON or to the proxy, we serve whatever they expect. In this case, we serve a robot.txt. Well, the URL is falling off, but in the end there's a robot.txt. It might be in a bit of an odd place, but other than that, it seems valid. So no harm done there. And then the next step is that the victim connects to us. Well, we don't want to serve the victim robots.txt, of course. So we serve the payload we want them to run. Next step. I'm going to refresh it again, because maybe a few days later, there's this user complaining, weird things happening on my machine, or my Windows sometimes disappears. At least we're trying to get Blue to trigger it. And the Blue team is going to look at this URL, because they've seen it a lot in logs, and what does it do? And someone looks at it and says, hey, but it looks like a Bitcoin stealer. That's bad, because Bitcoin stealing is bad, but as we're not into Bitcoins, it's no harm for us. So we can continue our normal operation. But still, it's interesting though. A Bitcoin stealer in one of our laptops. Let's have a colleague look at this as well. So they also visit the URL and look at the Bitcoin stealer some more, and they decide, well, again, it's not evil for us as we don't do Bitcoin, but it might be time to call in management, because at least we have some sort of an infection going on. And they go to management, have a beamer on, and they show the problem there. And this is what they get. Of course, in a real operation, we wouldn't move on with this picture. But what this is doing, there was this one unique key in the URL, and it's just keeping a log file of how often it's called, and based upon the number, the first time you get robots, second time you get payload, and so on. Basically, the code for this part, this is another dummy it plays with user agents, but this is all the code, 24 lines you need to build something like this. So if you take the tool we've developed and you start playing around with only a few lines of Python, you can get this kind of behavior. And you can multiply it as much as you want. You might write a small plugin, and there you go. Well, how does this improve red teaming? As we said before, we want to see red teaming as a boxing game. We want to play with the opponent. Let them hit us and we'll hit back. And that's the way, if you never get to train, how can you ever win a real fight? We want to have the blue team onto the skill level where they've trained enough to win a real fight. And in this case, it can be a good decoy. If we think the blue is going to get too aggressive on us, we try to ease them down a bit in the hope that they'll think, it's just a Bitcoin code, a Bitcoin stealer. We don't have to file a real incident for this. We don't have to call an external party to investigate this, and they might just move on. Doesn't work always, might work sometimes. Well, then the most important things for today. What should we remember?
If the party yesterday was really too heavy on you, or if you really just did not get anything of what we're saying, just try to remember those 3 things. It's very simple. Boxing instead of the wrecking ball. Red Elk, we're releasing it right now. And Blue Team, dear Blue Team, OPSEC. We can see things of what you're doing. So, yeah. I think it's time for questions.
If there are any.
And while maybe people are asking questions, I will get GitHub up and running.
It will be in GitHub in no time. At least the red file is on my laptop, so I'll grab it in a minute, and Red Elk is going on there right now.